improper integral because one of the limits is infinity. So if we take a look at the graph, 1 divided by parentheses 1 plus 2x plus x squared, and change the window so that this goes from 0 to even 10 should give us a decent idea of what's going on. You'll see that it's a very, very short function. So the area, as you go from 0 to forever, should be finite. Let's get an estimate. So integrate it from 0 to 10. Turns out the area is not even 1, at least as an approximation. So it seems like the answer is probably going to be 1. Let's see. So with this, U substitution is not going to work. This one could be factored, so we should go ahead and factor the denominator. Usually when you start by factoring the denominator, it's going to be partial fractions, but this one turned out to be a perfect square, so with that we can just use U substitution. So let U equal the 1 plus x, then du is equal to a dx. So this is simply going to be integrate a 1 over u squared du. Or in other words, integrate u to the negative 2. So if you add 1, that's going to make the exponent a negative 1. You then have to divide by that negative 1. So we've got negative u to the negative 1. Or in other words, don't leave negative exponents, so that's going to be 1 over u negative, and then replace u with 1 plus x. Alright, now that we're back to the x system, x goes from 0 to infinity. And hopefully we get the answer 1.0 out of this. Let's see. Well, you start at the top, use infinity. Technically what you're supposed to do is say, now take the limit as x goes to infinity, etc., but I think that we can use logic instead. If this is infinity, you're saying take 1, divide it into an infinite number of pieces. How big is each piece? Well, if you're dividing it into an infinite number of pieces, every piece is going to be infinitesimally small, so that produces a 0. You then subtract. Now substitute a 0. If you put a 0, you've got 1 over 1 with a negative sign. Negative 1 over 1. So it turns out that our calculator's estimate was pretty good. The answer is 1.0.